Atoms are really small, too small to count, but we still need to know the actual numbers of particles taking part in a reaction, rather than just the mass or the volume of the substances. And that is where Avogadro's number comes in. A mole is an amount of a substance. If I asked you to get me a pair of rabbits, you'd go get me 2. If I asked you to bring me a dozen cupcakes, you'd bring me 12. If I asked you to bring a mole of something, you would bring me, 6.02 times 10 to the 23 of them. And this is known as Avogadro's number, or sometimes the Avogadro constant. The clever thing is that 1 mole of any substance weighs its atomic mass or molar mass in grams. So if we know how many moles of a substance we have, we can easily figure out how many particles we have. Let's look at an exam question. How many sodium ions are there in 1.50 grams of sodium oxide? Well, the first thing we need to know is how many moles of sodium oxide we have. Number of moles equals the mass divided by the molar mass. The mass is 1.50 grams, and the molar mass, the atomic mass of each sodium is 23 and 16 for oxygen, and I can look that up simply on my periodic table. Shove that into my calculator and I come out with 0.0241935 mole. It's very important not to round up till you get to the end of a calculation. If I were to break up sodium oxide, I would get 2 sodium ions and 1 oxide ion. The ratio of sodium oxide to sodium ions is 1 to 2. But I haven't got 1 mole of sodium oxide. I have got, we've just worked it out, 0.0241935. So I should have twice as many moles of sodium ions. So 0.0483871. And we're still working in moles at this stage. Now we know that 1 mole of sodium ions is the equivalent to Avogadro's number, 6.02 times 10 to the 23. But once again, I haven't got 1 mole of sodium ions. I have got 0.048381. I've got that many moles. If I times it by Avogadro's number, 6.02 times 10 to the 23, I will know exactly how many ions I've got. So that's 2.91 times 10 to the 22. And at this point, I've rounded up to 3 significant figures. Because electrons are so very tiny and they weigh pretty much nothing, we can ignore the fact that we're working with ions rather than atoms. You can find practice Q&A at crunchchemistry.co.uk. Just search for Avogadro.